And we're back. So we have been talking about this wonderful substitution method. We're still doing the whole integration with the integral sign. We still have our integrand, or f of x, which we know that's the derivative, and with respect to dx. So what we're basically doing now is we're saying, well, let's substitute f of x, our derivative, as u, and then our d of x has to match. This variable has to match. So all we're doing is we're putting our integrand, our derivative, in terms of du to be able to match. Okay. Now, as you noticed on the last video, the factor 2x was always the inside function on every single example. Well, what if it's not? Well, what do? Well, let's see. So looking at something like this, I can see that, first of all, I would call the inside the t squared plus 1. So let u equal t squared plus, I don't know why I wrote that up there, plus 1. Then I take the derivative of it, which would be 2t dt, because the constant goes away. And I notice over here I see a t and a dt. Now what I tell students when you first learn this, why not rewrite the order? So notice I'm going to put the t dt together, because that shows me this I'm already okay with. I have e to the u. But this, I have a 2t dt. No problem. You can divide off values, numbers, okay? You cannot divide off variables, but you can divide off numbers, because notice now this becomes t dt, which is exactly this. And then typically I write this as 1/2 du, and you'll see why. And so where I see t dt, I put 1/2 du, and then I write the 1/2 out front. That's why I kind of separate it. So I have eu du. Well, now I simply take the antiderivative of e to the u, which is just e to the u. And then my last step, I would plug back in my value of u. So my u gets plugged back in. Okay, so you don't have to worry if you're not getting that exact, the leftover piece, as long as it's just a number, because you can multiply or divide it off. So let's see if I have something like this. Get my colors going here. Once again, I see an inside, looks like it would be that. So let u equal x to the 4th plus 5. As you work enough of these, you'll start to notice, why am I picking this? Notice the leftover is 1 exponent smaller. And what happens when you take the derivative? It becomes 1 exponent smaller, dx. I see an x cubed dx, but I don't see a 4. Not a problem. We'll divide that 4 off. And now this matches exactly. So now I have the antiderivative of the square root of u. My x cubed dx becomes 1/4 du. And then, of course, we like to write the square root to the 1/2 power. And then we take our antiderivative, so 1/2 plus 1, 1/2 plus 1, so 1/4. And then this is going to be u to the 3/2, because we'll make 1 2/2, 3/2. And then finally I can flip, so that becomes 2/3. U to the 3/2. 2 can go into 4, so I get 1/6. My u is x to the 4th plus 5, and then to the 3/2 plus c. So certainly, hopefully, you're seeing the whole key here is, how do I know what to substitute? Because when you take the derivative of it, as far as exponents and variable wise, it'll be the leftover piece. All right, so we'll continue with some more examples in the next video.